My name is Jennifer Bourgeau, and I am the United States Country Coordinator for the GLOBE program. I'm happy to welcome many new names and faces here, and there's some familiar ones who I haven't seen in a while, so that's also great. And I was really excited when Elizabeth brought this idea because science and math always seemed like a natural fit in GLOBE, but it's something that we often only talk to science teachers when we start talking about GLOBE. And I really think that with the data that we have, this data literacy, there's all these connections to math. And so I'm really excited that Elizabeth brought this idea and then introduced us to Steve Phelps, who will be talking about that as well with her.
I want to say thanks so much for joining us this afternoon or this morning or wherever you are around the world. I am so excited to introduce you to, I'm the new president of the Steve Phelps fan club, and I am standing in between you and Steve. But I want to do my due diligence to tell you that I have shared the link to, I'm calling it my show notes. The show notes for today's session, you will find the presentation, you will find various other key documents and that we're actually going to be using in the time that we have available. I want you to make the most of the time that we have. We don't have a full hour, I don't believe. Use the chat, unmute yourself when you can and ask questions. So we have a caveat, at least one, and a takeaway. The caveat here today is that we assume that you have some knowledge of how to access data from the Earth System Data Explorer or from the GLOBE ADAT system or any data portal that you choose. We are going to be using data today, and we have a data set for you to use, so have no fear. The takeaway today is that I am really excited for you to get some hands-on experience with this Desmos tool. I have heard about it, and not until I met Steve did I learn about its wonder. So I'm really excited about that. So for today, we're going to look over some of the NGSS science and engineering practices. Very basically, I'm going to highlight some of the features from the Earth System Data Explorer, and then we're going to introduce Desmos. Actually, we are not. Steve will introduce Desmos to you, and we've got a lot of fun things that he's going to highlight for you. I do want to highlight for you the where math comes into the science practices with data. And so here we have got, I've highlighted, I don't know if you can see, the two pie pieces of these different practices that use math and the models as we're going to be using them. There are one of the pie pieces of the investigating practices, which is using math and computational thinking with data, and then also the sense-making practices of developing and using models to explain data. And so those, I wanted to highlight those for you. The Earth System Data Explorer, this is the MyNASA Data data visualization tool. I know I'm preaching to the choir of you Globies, you've heard of it, many of you have used it. But the benefit of this tool is that very, very quickly you can create maps like this one here, line plots of a variety of, actually of the whole globe. So you just need your latitude and longitude in degrees, decimal degrees. And you can also download data as what's shown here. And so what we've done is that we have downloaded some, I think it's 3 or 4 data sets for Steve to use with Desmos. So just know that if you're interested in learning more about this, have no fear. I'll be there for you and we can work together outside of this presentation. I did want to mention, while I have you as a captured audience, we have data sets related to GLOBE protocols. These are NASA satellite data and other agency data. So, and these are linked in that show notes. So if you are interested in doing more with data, please do check those out. My friend Angie Rizzi has done a great job in making those accessible. So the data for today's session has been retrieved from the Earth System Data Explorer. If you go to our website, it's under the Visualize Data link, and so it's shown here. And also have no fear if you don't know it, you're confused by it, whatnot. We have all kinds of different guides for you. We have YouTube tutorials and playlists in YouTube. We've got, if you're a paper and pencil kind of person, we've got those available for you as well. And then also we are available from the MyNASA Data team to meet with you in a one-on-one session through our office hours program. We have a link. We use a program called Calendly, and so you can schedule time with us. So I wanted to mention that. Also, just want to, if you're joining us new today, after I mentioned this earlier, there are some steps that have been skipped, so we can go straight into the tool with Desmos. So we are skipping how to locate data in the Earth System Data Explorer. We are skipping how to access data tables, as well as how to download them in CSV format, and also about uploading data into sheets. So all those steps have been skipped for you, but again, we have resources to help you if you don't know those data moves. So in the show notes, if you will, thank you so much for sharing the show notes. Let's see here. If you were to open the Watercooler show notes, get out of this presentation for a second. All right. You should see that there, right about here, is the link to the data sets used in today's session. So please go ahead and open that for us. Okay. And so in this data set, you will see, and actually, I'm going to, sorry about that. I'm going to get rid of those so not to confuse you. You should see 4 different data sets. We have linear, sinusoidal 1, sinusoidal 2, and exponential. Each of these data sets has been downloaded from the Earth System Data Explorer, and these are available for us to use with Steve. So I wanted to show you how you can move back and forward between the different worksheets. And so at this time, I'm going to introduce you to Steve. I think you're going to be shocked and wowed by him as much as I am, and I'm really excited about what he's going to teach us to do today.
How's it going,
so Steve,
everyone?
All right, I'm going to quit sharing, Steve.
Okay, that's cool. So help me out for a second, man. I see some faces, some screens are muted. That's okay. So if you want to drop this in the chat, that's all right too. Have you guys used, have you guys know of Desmos? Thumbs up, thumbs down, thumbs to the side. I see some heads saying no. I see some, oh, really? So I bet your math teachers do. So Desmos is first and foremost a graphing calculator that is web-based. And oh, you guys are rocking in the chat. Thank you. But so on one hand, it's a graphing calculator that kids can use. It's on the state test in Ohio. It's probably on your state test. In math and in science, if there's a science state test, that might be the calculator that's also available on the state test. On the other hand, there are a collection of activities that are pre-made that are primarily math, but it's also a platform that is super easy for teachers to make their own activities. And for a science class, I think the potential of Desmos Activities in science really is large. So what I will do is, before I get to the data, I want to give you a kind of a sample of one of these activities, what a Desmos activity is like. So in the chat window, oh, Christy, nicely done. So you might know this. In the chat window, there is a link, student.desmos.com join. And if you want to click on that link, you might need to enter your name. You don't need to log in with a Google account unless you want to save your progress. This activity is a in Desmos terms, it's called a marble slide activity. And the thing that really, I know this is super, super hard. This is super hard when you're doing this remotely. The power in Desmos is what I can see on the teacher screen. I can see all of your screens, and I can see if you guys have had success or not. So on this screen, there's a launch button in the upper right corner of your graph. And if you click on that launch button, you'll see some marbles that fall and roll along that ramp, if you will. And then in the upper left corner of your graph is a star that kind of sits in a cup. And your task, should you choose to accept it, your task is to drag those points on the graph and see if you can redirect the marbles into that cup so it knocks out the stars. So that is your task. And so I've seen a couple of folks have already done this because on my teacher dashboard, it shows up as a check mark. And so this has been a wonderful remote learning tool during COVID that math teachers have been using. Also foreign language teachers. There's a huge Facebook group for foreign language teachers that are using Desmos activities. So I'll give you guys just I'm gonna set my clock. I could spend all day on this. I'm not gonna spend all day on this. I'm gonna set my clock for a minute. So, and that'll give you a feel for kind of how a Desmos activity behaves. Oh, I've got a lot of check marks on this, and I've got some dots, which simply mean that you're still working on it. And so you can redrag the points and move the points around until you reach your goal. This is typically done in a math class where kids would enter the equations, but I was trying to think of something that was sciencey that might involve projectiles and launching off ramps, and this is one of the things I came up with. So we've got about 20 more seconds, and then I will pause and we will go to the next thing about the MyNASA data and how we can use Desmos to help us analyze some of that data. All righty, kids. All righty. I don't know if you could see my screen. I don't think I shared my screen, did I? Let me share my screen. I know. And you guys either were saying maybe I'll just go away in a little bit if we won't share a screen. Let me share my screen so you can see what I was seeing on my screen. So on my screen is, this is the teacher dashboard. So this really is what makes Desmos and Desmos Activities so powerful, is that I can see what the kids are doing. So I can see what Katrina's screen, if I click on Katrina's screen, there is Katrina's screen. And if I move this Zoom window out of the way, I can test it out on my own and see what happens. And there it goes. Nicely done. Nicely done. So you get that instant feedback. So most Desmos activities are kind of very engaging this way. And if you can find some science ones by Google searching, they typically exist. Another, we're not going to do this one, but I want to give you some samples of what kind of Desmos activities exist. Here's one. This is called a polygraph, which is about phases and mixtures. Man, I don't know when this would be done. Is this, I feel like a science novice. So in a polygraph activity, what polygraphs are, hopefully someone in the chat is posting, chemistry, thank you, thank you, thank you, thank you. So in a polygraph, kids are randomly paired up with other students in the class. And this is kind of like you're kind of like a 24 questions, but it's only 4 questions. You're trying to ask 4 or 5 or 6 yes and no questions. One student chooses one of these cards, and the other students are trying to guess using proper vocabulary and precise language what card you chose. I have used these activities with second and third graders as they were working on their math vocabulary. I've used this in social studies classes as they're trying to work on historical events and presidents. So there's a lot of applications and they are very easy to make and you can do those things. And so another thing on here is the MyNASA Data. And these ideas that are called data literacy cubes. And so if I go to the, this is an activity that we created, you're going to mess with some of this data as well. If I go to the next slide, we've taken these, I can't believe, when I first saw these, when Elizabeth showed me these data cubes, these data literacy cubes, I couldn't believe I hadn't seen these things before, because language arts teachers use these cubes as story starters all the time. And so now it's a data literacy cube. And so in these activities, you can roll the data literacy cube. Well, it came right back up. Let's see if we can get something different. So just as simple as examining the graph. And so on the next page, there will be different questions that your kids can answer based on that analyzing the graph that came up on the cube. And so these are, in these activities, you can copy slides from one activity to another. So you could take this activity and copy the things that you liked and do away with the things that you don't like. So these are activities that are there. As someone said in the chat that they'd use this often. You probably have some math teachers at your schools that may use them. And if you're still in school, ask them about that tomorrow. And you can always reach out to myself, that I'd be more than happy to help you kind of get started with Desmos, and if you want to try to explore this further. Now let's take some of that data that was on the that spreadsheet, and let's place this in a Desmos Calculator graph. So I'm going to drop this link in the chat, desmos.com. This is probably, yeah, I thought that, Tracy, I thought that was, if the awesome was the data literacy cubes, that was absolutely. And the touch panel, yes, it will all work on the touch panel, provided your touch panel is oriented well. That's the only thing. But this is there's one of the schools I work with. They're a big Desmos users, and they haven't had any trouble with that. So in this is typically, when I mention Desmos to most math teachers, even most of them think this is the graphing calculator is what you're talking about. And in the middle of your screen, if you click on that graphing calculator button, it's going to open up in a new page. And this is the Desmos graphing calculator. In the state of Ohio, from Algebra 1 and above, this is the calculator the kids have access to. And my guess, on the math tests in your state, chances are this is the calculator that's available to your kids online. So I'm fairly certain that there's over 30 states now that have the Desmos calculator in their math classes. And it is super easy to use Desmos to help analyze data. And you can create activities where the kids can, like in your entire class, can put in all their data and they can all work on analyzing it together in an activity. So I'm going to go back to this. I'm going to go back. Better move some windows. Man, when you get on Zoom, there are so many windows around. The windows are everywhere. I have to move them all over the place. So I'm going to go to the very first linear fit example. This is going to be absolutely probably the best one to work with. And the only thing I'm going to do is I'm going to copy all of the numerical data, and I'm going to start with the 0, and I'm going to hold my mouse down, drag over, and I'm going to drag down. I believe there are 80 bits of data. And so I'm going to 80, I think it started at 40, 20, 85. So I'm going to get down there at the bottom, and I'm just going to copy that data. So I'm going to come Control C on my keyboard. And so it's on my clipboard. And so what I can literally do is I can take this data and I can delete or delete, I can paste this data right into a Desmos calculator. So I'm going to go back to my Desmos calculator. And I'm going to click in that first line in the upper left-hand side and either right-click on my mouse and select paste if it exists. I don't see it selecting paste. So I'm going to go Control-V instead. And this is all of my data. This is all of my data. And so there are 4 columns in my table because we copied 4 columns over. And the columns I don't need, I can turn off. So if you'll look at the graph for a moment, there is this purple line of data that's at -22, and this green line of data that is at -42.5. And in the chart, that's the purple dot, which I'm going to click on that dot right there and turn that off. And I'm going to do the same thing for the green data, and I will turn that off. And so the only thing that is left is this U data, which is probably hidden somewhere. But if I scroll down to the bottom of my table, there's a magnifying glass. I don't know what's going to happen when I click on this puppy. I'm going to click on it and see. So, oh, there it goes. There it goes. So I get a very, very quick scatter plot of my data. If I was an AP statistics student, I would say this is strong, linear, positive, no unusual features or outliers that I could tell. And since I can't see anyone's screen, I'm going to hope you guys are able to follow along, but I also understand if you're not able to follow along, that's okay. So there's a couple of things that we can do, with our data. These values are in list U sub 1. If you just type in a U and a 1, you'll get it. So we could actually do some very quick data things. So if I click on line 2 over on the left-hand side below my table, if I typed in the word stats, all lowercase letters, and then right after stats, if I opened up a set of parentheses, inside of those parentheses, I could type in a lowercase u followed by a 1. And so this gives me a 5-number summary. So I know where the median data value is. I know where my 2 quartiles are, and my minimum value and my maximum value. And that is just the y values or the dependent values in my variable or in my data. I can also find a line of best fit. And let me zoom in, see if I can make my screen a little bit, this might be better. If I wanted to get any, ooh, hold on, someone put it up there. Can you change it to a box plot? Angela, that's a fantastic question. So if there was a command for box plot, it would probably be box plot. So I'm going to give that a try, and there it is, box plot. There's a couple of things that we'll probably have to do on this. So when I type in parentheses, I go U1, and notice on my screen, Angela, there's an offset and a height. The offset is where I would like my box plot to go. And looking at my data values and my y-axis, I would probably want this to go around 385. So my offset will be 385. And I think my height will be, maybe I'll make my height to be like 10. Up. Oh, what? Oh, I know why. It's, yeah, because it was on my y-axis. I was looking at my y-axis, and I actually, yeah, so the box plot is taking your y values and turning them into a horizontal. That's the only thing that's kind of weird. I wish I could make a vertical box plot, but yes, you can make a box plot. And I was looking at it the wrong way. I just get so excited when I do Desmos, but I just forget what I'm doing. So great question, great question. So let me get a line of best fit, a line of best fit. So the line of best fit will work like this. I'm going to go U1, and to get a line of best fit, we don't use the equal sign. In statistics, we use the tilde symbol. So I'm on a Windows keyboard. Mac keyboard works the same way. In the upper left-hand corner of your keyboard, right above the tab key, is a small key right next to the 1 that has like a kind of a back tick, and there's an ampersand right above it. So I can hit the shift key and get my ampersand. And then the, oh, there you go. Good. That was a teacher technique. I just get so excited, Elizabeth. I get so excited about Desmos. And so now if this is a linear equation, it's going to be something like an A times X1 plus B. Or you could go B plus A times X1. So I know that in statistics, we kind of write that with our constant term first, but math, I don't know what science does. In math, I'll write it with the slope first. But I will go A times, and the time symbol is the asterisk above the 8 on my keyboard. But you could also just type in X1 and it would recognize that as X1. And then I need to go plus B as my y-intercept. And so I've got all of my my graph, which is plotted. And I can, this is a very strong, my R squared is quite high. So this model does a nice job of predicting y-intercept, slope. And then if I wanted to use this variable to make a prediction, like in month 40, I could go to the next line. I could go A times 40. Oh, not that. That was a teacher technique again. A times 40 plus B. So in month 40, my model predicts there will be 394 of whatever that stuff was, the carbon dioxide concentration in parts per million. So talk to me, kids, talk to me. Questions about things so far, questions about things. And Elizabeth, I have no idea how much time we have for this.
I don't either. Jen, how much time do we have? Are we having fun yet, everyone? Come on now. Questions? What's getting you excited? Hey, Steve, could we try a different data set?
Yes, we can. Yes, we can.
So about, people can put in questions in the chat, about 5-10 minutes for more stuff, maybe.
That'll be, so I'll do one more data set. I'll go 5 minutes. We'll take one more data set and then we can we'll give some folks time to put questions in the chat. So I think the easiest way to do this, I'm just going to X out all of the things I've placed in. And now I'm right back to the beginning. I'm right back to the beginning. And I'm going to go back to my spreadsheet that I had before. And the sinusoidal is fun, but I think the exponential might be funner, if that's a word. So I'm going to go to the exponential data. And I am going to grab let me change my screen. There it is. I'm going to grab again the time, months since 2/1/2010, and the number of new COVID cases. So I'm going to try to grab all 4 columns of this data. I may do a little bit of a, I wonder if I could kind of like, I'm going to have trouble with that. So I'm not going to do it. I'm not going to do it. All right. And move my screen over. And I'm going to start with number 1, and I'm going to drag over to the COVID cases in Atlanta, Georgia, and I'm going to drag down. And there's not much data. There are 13 months of data. And so I'm going to grab that data, and I'm going to copy it, Control C. And then I'll go back to my Desmos calculator. If I was doing this with kids, I would probably create an activity with the data already pre-populated in a table, because the copying data might not be the most important thing. Maybe the analyzing the data would be. If you were doing something in your science class where you were collecting data, you could set up an activity in your class where all of your kids could input their data through the activity, and that data is available to all of the students to analyze in real time. So that is another thing that's also an easy thing to do. So I'm going to click in that very first row up there in the upper left-hand corner, and I'm going to paste my data. And just like before, the longitude and latitude data does not matter. So I'm going to click on the green dots at the top of the table. And I'm going to click on the purple dots on the top of the table. And so these are the number of COVID cases. So I'm going to scroll down to the bottom of the table, and I'm going to click on the magnifying glass. And this is nice data. Oh, my goodness gracious. So that is my data. So exponential. So this is what I really like about Desmos, is if you know what your model is, ooh, I was looking at the questions in there. That's okay. I'll put those chat. I was looking at the chat for a second. So let's do our kind of a exponential model of best fit. So I'm going to scroll at the top again. My y variable, my dependent variable is u1, and my independent variable is x1, so my x-axis by default. So I'm going to go down here and I'm going to say u1. I'm going to use that little tilde symbol again, that little tilde symbol. I'm going to click on the tilde symbol. And so this is an exponential graph. And so I think there is going to be 2 variables to use. There's like a scale or a multiplier, and then there's a base raised to the x1 power, maybe.
Steve, how'd you do to raise to the x1 power?
Great. That is the caret key right above the 6 on my keyboard. Thank you for stopping me on that. That was not very clear. So yes, so I've got my A times B and then the caret key right above the 6. And then I have to type in x1. And when you type in the 1, it automatically puts it down in a subscript. And as I'm looking at the data, the R² value is not very large. So my model's not going to do a very nice job of predicting. But still, it certainly illustrates this kind of an exponential growth over time. I would never want to predict what's going to happen in month 15, but we could predict, because that would be extrapolating. Extrapolating is probably not very good. But if I go A times B raised to month 15, so that is right about 9,000 COVID cases, and we could actually graph this if we wanted to and place that point on that.
Steve, Christy has a question with some of the time left. Could you show us how to set up an activity? So would you be able to do that for us?
I will do that. Okay, kids, ready? This really is, I think, using a Desmos activity is super easy to do. And so where we'll go is we will go to teacher.desmos.com. I'm going to copy this link and I will put this link in the chat if I can ever find the chat. I never know where the chat goes in Zoom. It always goes behind every window that's open, no matter what you do. At teacher.desmos.com, I will, Bo. And teacher.desmos.com, in the upper right-hand corner of your screen, if you've not signed in yet, go ahead and just click on sign in and use your Google credentials. I don't know if your school is a Google school, but if it is, just use those credentials. Or if you have your own Gmail account, use that. It's going to be easier to do. And since our time is short, I want to make sure I can get you started with an activity. So do me a favor, if you are following along, if you're ready to go, if you've gotten this far, you've gotten to teacher.desmos.com and you've signed in the upper right-hand corner, if you would do me a favor, if you would just maybe put a Y in the chat to let me know that you guys are ready to go to the next step and how I can get to a custom activity. Perfect, perfect, perfect. Now, this page I'm on is like my teacher page. My page is going to look different than yours because I've got other things on there for the things I do with Desmos from time to time. On the left-hand side of your screen, most of these things that you will see are going to be mathy things, but there should be a link that says custom on the left-hand side. Click on custom. And again, if you've not used Desmos before, your screen is going to use different. It will probably be blank. In the upper right-hand corner of the screen, there is a link that says New Activity. Click on New Activity. And if this is your first activity, you might as well name it First Activity. Christy, are you looking for the link to that Google Sheet file with the data? Is that what you're looking for?
When you clicked on something, I just happened to see in the right-hand corner NASA Data, and I got all excited because I teach aerospace engineering.
I will drop a link to that activity in the chat for you.
Thank you.
You're welcome. And I'm going to click on Create New Activity. So if you've gotten, if you are at a screen that looks like this, if you would just drop a Y in the chat for me, let me know. At least I know we're all this far, and I'm going to grab this link and I'll drop it in the chat. And this is the one that had, oh my goodness gracious, all of these Zoom windows. Let me copy that and I'll drop that activity in the chat for those of you who want that. And if you grab that, and so I'm going to go back to our activity builder by Desmos. So on the left-hand side of your screen, these are the different components or elements that you can add to a slide. Now, at the top of your screen, if there's you'll see a plus sign, a white plus sign with a circle around it. And that's how I add additional slides to my activity. The marble slide that we did earlier was only one slide. In the meeting I was at before this one, we were going over an activity that had 30 slides. So it just depends what you're working on and how detailed they are. So I'm going to click on the first slide, and there are different things that you can add. I can add a note component, and this is typically maybe just used to give instructions. And I'm going to click on the 3 vertical dots in the upper right corner, or horizontal dots in the upper right corner, and I'm going to delete that component. And then I'm going to, another thing I can do is I can do text input. This is where students could type in an answer to a question that you've asked, and you would be able to see all of their answers. This is also where students could upload an image of any written work that they have or of any notes they have taken. They could upload an image, but you would need to turn that on, and I can show you before we leave where you need to turn that feature on. But this is called a text box. Now, Desmos is designed to get kids talking and teachers talking and kids and teachers talking back and forth. So there's always this checkbox. Do you want students to see what other students have written? And again, this is all about creating conversations in your classroom. So I like to leave that checked, but I also know some teachers would rather not leave that checked because they're trying to do some other things. That's okay. I'm going to click on the 3 dots up here in the upper right corner, and I'm going to click on delete that component. There's a math input. And this is simply if I wanted to, like, if I had a numerical answer and I could ask students to explain their answer, and I could see what other students have written if I check those off. And what that would look like if I go in the upper right corner, there's a blue preview button. You could see what it would look like from the student point of view. And it's just a number. Behaves kind of like a calculator, and I could submit it, and then I could see other student answers or maybe a box that would show up asking me to explain. These other 3 things, a multiple choice box, this is exactly what it looks like. And I can give students graphs, math, images. I can ask students to explain their answer, and this could be graded for me. At least I would know on the teacher page, like that I shared at the beginning, if a student has it correct or not. And I can easily change this to like a radio button look or a toggle button or tiles. It's a lot of flexibility. If I have more than one answer, I could convert it to what's called checkboxes. And an ordered list is exactly what an ordered list would look like. I'm going to delete this component. An ordered list would be a list of things that you might want to put in order. So I'm thinking of like planets. Put the planets in order from closest to the sun to farthest from the sun. I think one of the more useful tools, I think from a science perspective, is the sketch component. If I click on the sketch component, I can add custom background images. I could add graphs, or I could leave it blank. But if I upload some sort of a custom image, can't go wrong with SpongeBob. Don't judge me. Don't judge me. Okay, ready. I'll go to preview this. And so here's what kids can do. Kids can insert text. Like, hello. I can, oh, thank you, thank you, thank you, thank you. I can do math stuff. So I can do a square root of 3. I can draw a mustache on him. Or I could do written work. So this is there's just so much you could do with the sketch component. So I have worked with science teachers who have placed like a diagram of the periodic table with no elements in it, just the blank diagram. And they've asked their students to circle where inert gases are, or to circle where these elements are. I have seen biology teachers who will give a picture of like a black line picture of cells, and they'll ask to label the parts of the cell. So this is certainly one of the more useful tools that I think you can use. And we're just, this is super duper fast, kids. This is super duper fast. And honestly, the creating the activity is one part. You can create this activity and get started tomorrow. Now, how do I get this to my, how do I get this to my kids? In the upper right-hand corner is a green publish button. If you click on the green publish button, it takes me to the teacher page of the activity. And then there's a green assign button. Now I can create classes within Desmos, or I can link this to my Google Classroom. Probably not going to do that now, but I'm going to do a single session code. And I'm just going to set it up for 48 hours because no one's going to do this. And if I create the code, then I can get the link from the dashboard to my students. So this is the link I would get to my kids. I'd put that in my Google Classroom or whatever LMS I'm using. And this is where all the student work would show up. And this is where the magic of Desmos happens. This teacher dashboard allows the teacher to orchestrate those conversations, to formatively check students in real time, to get kids to talk about the content back and forth with each other and to the teacher. And remote learning or face-to-face learning, this is a tool that you can use in any class. I've used it with language arts teachers. I've used it with foreign language teachers. I've used it with social studies teachers and science teachers. I've actually used it more with non-math teachers than I have with math teachers during this past year. So, all right, that's that. I hope I did not go over our time.
Steve, there's lots of chatter about having a part 2 of this session. And I'm thinking if you're amenable to it, it might be interesting for people to bring their own globe data that they want to visualize and analyze. That might be something fun to do.
We can do that. That'd be fun.
Thank you, Steve.
Yep.
Well, I appreciate your time in this, and thank you everyone for joining us. Hopefully it gave you some ideas about how you might use your globe data or how you might use data from MyNASA Data.